Right. You remember that so far we have done computer systems and management information system, relational database management systems, information theory and practice. Yeah.
Yeah.
1 second. Now it's more important to note that like system analysis and design, relational database, or management information system, even the information systems theory and practice, yeah, like these units are basically give an idea, a relation to the software. Do you agree?
Okay, yeah.
Yeah. So let me catch up that any of the software related units are being a kind of subcategory of software engineering. They have to go through the software engineering.
Okay, yeah.
Yeah. So this unit as a software engineering is a unit that we would be discussing and starting its first learning outcome today. And most of the things, like we have already discussed that what are the models of the software engineering, models of the software development, what is the system development life cycle, and as I explained that the software engineering unit itself is a kind of broad study. Yeah.
Okay.
And since you have already done these units, so you would enjoy this unit, and we can skip few other things, but we will go through all of them. Yeah.
Okay, yeah.
So let us look at the unit specification of software engineering. So it has 3 learning outcomes. Yeah. So one is the understand the software engineering approach to design and develop the software. So most of the topics would be related with the software engineering principles, process and development, some traditional software development approaches, process modeling, agile software development, software modeling, and you must have heard these in previous units. Yeah. Then unit 2 is analysis task, design task, implementation, and the learning outcome 2, development, software development and business information, and organizational aspects of software development. Can you hear me?
Yeah, you broke up just a minute ago, but I can now, yeah.
Okay, you are back now. So,
yeah.
So overall, the LO1, LO2, and LO3, they are related with the software. However, they would fall under the requirements, analysis, design, implementation, and testing.
Okay.
Right?
Yeah.
So keep in mind that if you are dealing with the software, dealing with the system analysis and design, or any database development application, or let's say the information system, so it has to go through certain requirements, then analysis and design, then implementation, testing, evaluation, and maintenance, and these things. Yeah. So just these 5 terms are basically everything, but it's needs lots of knowledge and process to go through.
Okay.
Okay. So let us start with the topic wise. Software engineering principles. So what's a software? Simply a computer program, associated documentation. Software products may be developed for a particular customer or may be developed for a general market. Yeah. So in this unit, we will be trying to relate our any program whatsoever our purpose is to look like as a product. Yeah. When you say you buy a software, then you basically buy a product. It is a product and product is that an entity like which has a complete, documentation and usage, and all aspects would have been, provided, discussed, and there shouldn't be anything, missing from it. Make sense?
Yep.
So what are the attributes of a good software? Good software should deliver the required functionality and performance to the user and should be maintainable, dependable, and usable. So if you have, for example, you purchase a software and they don't have, any support or, bug fixing or any, features which you can, maintain, yeah, and so that won't be a good software, right?
Okay.
Software engineering is an engineering discipline that is concerned with all aspects of the software production. Yeah. So as I said earlier, if you want to produce a complete product, it means that would be, that has to go through a production, and obviously a production has many concerns, many aspects that you need to, consider, and once those aspects are taken care, then it means it's a complete product. So software engineering, asks you, it gives you the information that you produce something by, considering, the from the beginning to the delivery and maintenance aspects, as well as, improvements, and lots of things, must be considered, no matter those, be used by everyone or not, but let it come into the market with everything.
Okay.
Right?
Yep.
So the reason that it's not the case that, for example, if you have designed a software for a particular person, yeah, and particular person may be, approachable to you, and you as a developer may be approachable by the customer, yeah. Yeah, but if it is not a software product, yeah, then it's only, possible that, you could communicate directly. But if it's a product and you want to sell into the open market, then you need to provide its all aspects, like how the software would work in the form of documentation, how someone needs to get the support through proper channel, through certain, website, through particular, contact number, and if they need, further any changes or any bug fixing, then the technical team might be the different. You must have, seen the different departments in different, companies. Yeah.
Yeah.
So for a role of software engineer, all these things needs to be considered as a professional, in a professional manner. Right? So that's basically the main idea of the software engineering, that it has to go through an engineering process.
Okay.
So now, what are the fundamental software engineering activities? The activities of software normally are software specification, then software development, software validation, and software evolution. Yeah. So difference between the software engineering and computer science. Computer science focuses on the theory and fundamentals, while the software engineering is concerned with the practicalities of developing and delivering useful software.
Okay.
Yeah, like, you can say that difference between the computer science and IT is that the computer science would give you the theories and concepts, and the information technology would give you kind of practical approaches in developing and are providing you the computing using, the practical approaches.
Okay, yeah.
So, difference between the software engineering and the system engineering. Software engineering is concerned with the all aspects of computer-based systems, system development, including hardware. However, the software and process engineering, so the system engineering, obviously the system includes the software, hardware, and process, while the software engineering is part of this more general process. So you can say that like in the world, there are certain degrees in the engineering, computer system engineering. Yeah, have you heard about it? Yeah.
Yeah.
So those are being taught, the hardware as well as software. Yeah. However, the software engineering is purely based on the software studies.
Okay, yeah.
So let's go to the next slide. Now the software engineering principles. What does it take to ensure a successful software development project? It now appears that there are at least 7 basic principles for that. Your software should be managed using a phased life cycle plan, perform continuous validation, maintain disciplined product control, use modern programming practices, maintain clear accountability for results, use better and fewer people, maintain a commitment to improve the process. Yeah, so these are the principles if you want to produce a good software, or if you want to become a good software engineer. Yeah.
Okay, yeah.
Now, manage using a phased life cycle plan. So normally the most of the projects fail because they don't come up with the project life cycle plan. Yeah. So essentials of a software project plan includes project overview, summary of the project, and ready by anyone. So you overview the project, that what is basically the project. Yeah. Phase milestone plan, description of products to be developed in each phase. Yeah. So milestones are called basically the deliverables. Yeah. What you would get, the at each phase. Yeah. If you don't know that what particular phase should give a what output, then your project would fail. Then project control plan indicates the project organization and associated responsibilities. Yeah.
Okay, yeah.
Project product control plan. Yeah. Identifies the major activities involved in software product or control configuration identification. So these are the two things. The project control plan is taken at the development stage. Yeah. When the software is completed, when it is handed over, then it becomes a product. Then after delivery of the product, how you would control it.
Okay.
So probably if you have designed a very big commercial project, a software, yeah, and it needs the deployment, a kind of continuous deployment activities and continuous control, then if you won't be able to control the subsections, for example, if it is an enterprise application and all components of the software work together, and if you don't manage the software as a product and you don't control, then your project would fail. Possibly, in order to run this good software in an enterprise, for example, spread over 5, 10, 30, 100, users, and if you don't take the advanced measures to, for example, the availability of the internet, the network bandwidth required for the software, then your software would fail. Yeah.
Okay. Yeah. Yeah.
Validation plan, the covers much more than the usual plan. Validation is basically the what you expect and what you are getting from the software.
Okay. Yeah.
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 Operations and maintenance plan includes an overview of the concept of operation for the system and plans for training, installation, data entry. So whatsoever the maintenance requires, yeah, including the installation and the post-implementation aspects, they needs to be done. So overall, these things are to be carried out in a phased life cycle plan. So everything needs to go through the phase. If you don't do, then your project would fail.
Okay. Do they have to go in that order that you've got on the screen there?
Depends, that if you recall, the system development starts with the specification, then design, implementation, and testing. Yeah.
Okay.
So
Yeah.
obviously, like the operation and maintenance would definitely needs to be done in the last. Validation is checking whether you have made the right product. This needs to be definitely the second last step, and control is the middle. And yes, I would say that these are basically these needs to be in this order, but mind it that these are basically the phases described in general. Yeah, if you recall the system development life cycle, yeah, in the previously discussed units, from specification to design, then implementation and testing. And but your question is valid. The uh, sequence of those steps is mandatory or not. The answer is that traditional software development approaches, yeah, advise to go through these stages in one sequence. However, the agile development approaches do not force you to go through the advised sequence. Do you recall that difference, the traditional approaches and the agile development approaches?
Yeah.
Yeah. So your answer to this question is that if you follow these approaches and the steps in a sequence, you do traditional software development. Obviously it has the advantages as well as disadvantages, and if you don't follow the sequence, then it would be agile, and agile has some advantages obviously as well as disadvantages as well. Yeah. So
Okay.
this question would be answered in the next slide again. How? Let me finish these principles. Yeah, and then we would come to start the software process models, and those models would be discussed under certain features, that what to start first and what to start next. Yeah.
Okay. Yeah.
Perform continuous validation. So as I explained, that there is one single message about developing reliable software which outweighs all the others. It is to get the error out early. Yeah. So getting errors out early is basically the principle. If you don't do this, yeah, then obviously your software would be won't be bug free, and you would be facing errors at the later stage, maybe in the usage. Is it possible?
Okay. Yeah.
The first step is to incorporate early validation activities into the life cycle plan. So each early validation subphase implies two things: the validation activity itself and a plan preceding it. So if you come back here, that first principle is that you go through a phased life cycle, which includes all of these things. Yeah. And second is that continuous validation is basically that if you always keep on validating. That's the second principle. Yeah. Because they have noticed that it is important to validate about the errors continuously. You never forget this, right? Let me go to the third, uh, maintain discipline, product control. Let me list out these first in front of you. Yeah.
Okay.
So that,
yeah.
I think it would, distract the attention that how they are coming, and basically the software engineering, yeah, unit and the subject itself is a totally theoretical, based on the lots of chapters, lots of concepts, and every learner would be confused at which topic I am studying. It happens. Yeah.
Okay.
But remember that the software has to go through the certain activities, and those activities are the requirements, then analysis and design, implementation, testing. That's it. Okay.
Okay. Yeah.
Yeah. So whenever you recall that which stage you are in, then you would have to think that particular terminology, theory, and concept, and then you would be, okay with this. Now, so the principles we are discussing, the one is using a phased life cycle plan. So the phased life cycle plan is based on, the from the overview to implementation until the operation. So like a phased life cycle plan is basically the kind of system development life cycle. And then the second, the principle is that to the, basically, that next slides are a detail of these, these things.
Okay.
Yeah. So that's why, I have put these things in front of you, that there is a mixture, but let us go through in the sequence by sequence. Yeah.
Yeah.
There's a little mixed up, the theory. Manage life cycle. So the continuous validation is, clear that we have to go through the, error discovery. Yeah, it's clear up to here.
Mm-hmm.
Yeah. The third one is this slide is again, continued for the validation. It is asking to go through the in-depth review. Yeah. Going through the early user documentation, going through the prototyping and simulation in order to validate and eliminate the errors. Yeah. So basically, the reason, I'm trying to go through quickly, and not reading these slides, because they are already, 43 slides. Yeah. And if I would go through one word by word, then we won't be able to finish. Yeah.
Yeah. We'll be here till midnight.
Yeah. will be at the midnight. So what I'm trying to say, that as I said, that the unit itself is totally, the theoretical, and you would be last, yeah, that in which, topic you are, yeah. But again, every time you will have to recall that, where you are, uh, trying to study the particular topic, then you would be on the same, you would be on the correct place, yeah. So the principles of good software engineering are 6, yeah. You go through a phase life cycle, then perform a continuous validation. So we are on the second slide of the validation. It further includes these things like in-depth reviews, user documentation, prototyping, simulation. And then we move forward on the next one. Maintain a disciplined product control. Yeah.
Yep.
So we discussed, in the first slide. So basically, these are the phases we are discussing in the detail.
Okay.
Yeah. Phase life cycles we are discussing in the detail. Baseline configuration management, the most effective system of software product control. A baseline is a document or program which undergoes a formal validation or approval process, and thereafter may only be modified by formal procedures. So let me tell you the one word, 3 word, definition of this. Maintain a disciplined product control is basically the configuration management.
Okay.
Yeah.
Yep.
If you have if you would be able to configure the product very well in a disciplined way, yeah, then your software would be fine, otherwise not.
Okay.
Yeah. Now look at the topic. We are discussing the principles of producing the good software.
So yeah. Okay.
Yeah. Next is use modern programming practices.
Okay.
Yeah. Third one.
Yeah.
So a few more slides on the maintaining a disciplined product control, like the configuration identification, configuration control, configuration status, accounting, verification. So all these related with how you would configure the software. Yeah. So obviously configuration is, let's say you have a software and you need to tell the software to create, for example, the spaces, instances according to available storage. Yeah. For example, if you have a database server, then the pool of the databases might be created, let's say 100 GB. Yeah. And if you haven't available the 100 GB in your computer, and if you created the configuration in wrong way, yeah, and obviously the system efficiency would be reduced, isn't it?
Yeah.
Right. So the configuration control would be helpful to give you a disciplined product control.
Okay.
Yeah.
Yeah.
Next, the use modern programming practices. The fourth principle is basically the top-down structured programming. Now, before I go into theoretical wording, let me tell you in simple words what is the difference between the modern programming and the old programming. Yeah. Do you have any idea of the programming at all?
What do you mean by that?
Okay, so so the question is not clear. It means you don't have an idea. Okay.
Yeah.
Okay, no worries. So basically, the programming started with, for example, machine language.
Okay, yeah, I've heard of that. That's
Yeah,
ones and zeros, isn't it?
ones and zeros, they're used to write a program. Even today, our computers work on these, programming languages.
Yeah.
On that programming language, that's basically the machine language, and a little, a layer given to it is using the assembly language.
Yep.
Yeah,
Yep.
assembly language is basically the kind of, a language where you write the program using a human language. Human language is basically, you write the English words to write a program.
Mm.
Okay, so the
Yep.
assembly language uses most of the English words like start, begin, for, loop, and these things. That's assembly language. Then the high level language, you write the computer programs using pure English language.
Okay.
Yeah, like algorithm, you write start, and loop, or switch statement, or the if statement in the high level language. Yeah.
Okay, yeah.
And by looking at the language, the old languages used to be like, the unstructured programming. Like,
Okay.
they used to start, let's say, from line 1, line 2, line 3, line 2, then line 3, in, let's say, in thousands of lines of programs. Yeah.
Okay, yeah.
Then they realize that, particular code becomes kind of spaghettis.
Yeah.
Yeah? So they introduce, the modular programming. They introduce the structured programming.
Okay, yeah.
Yeah. Then
Yeah.
they introduce more advanced options. Yeah.
Yeah.
Object-oriented programming. Yeah.
Yeah.
So the principle is, the fourth principle, you uh, incorporate, you use modern programming practices instead of the older programming languages. The modern programming languages have, more uh, uh, advantages.
Mm.
You got it now?
Yeah, I understand that, yeah.
And obviously, you notice that the modern programming languages would be difficult to understand or manage or, use maybe, and but they have more advantages,
Mm.
right? Then maintain clear accountability for results. Yeah, do you get that?
Yep.
How?
Number 5. Yep.
Yeah. um Instead of I read this, can you give me the example?
Maintain clear accountability for results. So that would be, basically, it would have to be, the results would have to be quite clear. What you expect the results to be,
Yeah.
it would have to be quite clear from the start. So if you expect it to do whatever it's going to do, A, B, C, it's got to do that. It's got to be quite clear.
Like, that you should not compromise with the results at all.
Yeah.
Yeah. If you are getting, any of the, for example, delay in a particular process, yeah. So process is, the result would be from the process, and you think, okay, no, for example, I'm ignoring this. Yeah. You should
Yeah.
not ignore, and you do a clear accountability for that particular result. If you would ignore, then it would give you a big trouble in the future.
Yeah. So really, you shouldn't take shortcuts.
Now, yeah, obviously not only the shortcuts, but if you notice that, for example, you requested 5,000, records in one command,
Yeah.
and you notice that it would need, a kind of 5 minutes of computing, uh, to retrieve the records, yeah. And you realize that either your computer is not capable to perform those operations within that particular time,
Yeah.
or you should not create a command which allow you to retrieve 5,000 records.
Yeah.
Make sense?
Yeah.
So the results, what you can achieve, you should be accountable for this, and you should not compromise. Okay, it won't be the case. For example, the human capability to take the load is, for example, you can carry a 20 kg bag, yeah, and if it is 21 kg, then you won't mind it, yeah. But the
Yeah.
computer, in your software engineering, you should not, give any leniency. Yeah.
Yeah. Okay. Yeah.
So accountability, and then next is the use better and fewer people. Yeah. So it looks like clear that instead of the increasing the quantity, you should have a quality team.
Yeah.
Yeah. So that's a
Yeah.
principle, and
I'm clear with that. That's fine.
maintain a commitment to improve the process. Yeah. So the 6 principles, yeah, they are not quite enough to guarantee a healthy software engineering organization. Still,
Okay.
yeah, they are enough to get an organization to do good, like 182 vintage software engineering. Yeah, but not enough to ensure that the organization keep up with these times. Yeah. So, like, however, those things may be good. Yeah, but you keep on trying to incorporate the uh, new models in the market.
Okay.
Maintain a commitment to improve the process, no matter these 6 things. Yeah, you use the good people, you have a good team, you are accountable for the results, you are using the modern programming, yeah, you maintain a discipline control product, you care about the validation, yeah, you are going through the phase life cycle, yeah, but still there is a need, there is a room for the improvement.
Okay.
Yeah. So these are the Hello.
Hello.
Yeah. And the seventh principle is, can you hear me now?
Yeah, I can now. Yeah, you're back now.
Yeah. So the software engineering principles, from first to sixth is like, the important. The seventh is that you should be committed to improve those six, principles, as well as be ready to adopt any new principle.
Okay.
Yeah, like, there's a saying that, you change everything. Yeah, that you still need to be ready to change any further.
Okay.
Yeah, so adopt these principles. And the seventh principle is that try to look into the detail if anything needs to be added.
Yeah. Okay.
So these are the principles for the good software engineering. Now we come to the, few more definitions, and I hope that these definitions would be, helpful for you to go ahead with the rest of the slides. Yeah.
Yeah.
What is the software development process? It is basically the structured set of activities for software production. Yeah. All software processes involve following activities, like I discussed in the beginning of the session today, that the requirements, design, deployment, like, in my wording, requirement analysis, design, implementation, and testing. These are the words you have to go through. Yeah. The other names to these, activities are requirement gathering, sometimes requirement analysis, sometimes software specification. Make sense?
Yeah.
Yeah. So they are the kind of synonyms. Yeah, alternative words. Then design and implementation, and sometimes coding is basically the word given also used for the implementation. Makes sense? Yeah.
Yeah.
Validation or testing is after the implementation. Deployment is basically the configuration. Yeah.
Yeah.
Evolution, maintenance. Yeah. You remember that evaluation is that have you written the product right? Yeah.
Okay. Yeah. Yeah.
What you intended, and have you got it right? And evolution is basically the changing in the system.
Okay.
If any change occurs, yeah, then you are able to deal with the evolution.
Okay. Yeah.
Yeah, make it.
Yeah.
Evaluation is EVA. It starts with evaluation, EVALUATE, and evolution is basically the changing requirements in order to support the changes.
Okay.
Yeah. So now the software process is based on these activities. Is that clear?
Yeah.
Next is process model. Yeah. A
Yeah.
software process model is an abstract representation of a process. It presents a description of a process from some particular perspective. So, yeah, there are 2 minutes left, but I would finish, the next two slides, and then you can, you would be on the right way to study the rest of the slides.
Okay. Yeah.
So process model is the abstraction. Process model is basically the software development methodology. Okay. So the
Okay.
methodologies, there are the traditional methodologies, and they are compared with the agile processes. Yeah.
Yeah.
The traditional methodologies are called the plan driven methodologies. Yeah. And the
Okay.
agile processes, they do not follow the plan in exact way.
Okay.
So the plan-driven processes are processes where all of the process activities are planned in advance and progress is measured against this plan. In agile processes, planning is incremental and it is easier to change the process to reflect changing customer requirements. In practice, most practical processes include elements of both plan-driven and agile approaches. There are no right or wrong software processes.
Okay.
Yeah. Very strong, points in order to answer your previous question that which one needs to go through, yeah, and which one is basically when it is a plan driven, it is a traditional one, and the agile is, without following those, and some at some stages may be mixture of both. So process model based on the, activities, and agile is somehow 50-50. Yeah.
Yep. Okay.
So you are aware with the principles of the software engineering now, and then you know what is the, process. Process is based on the activities, like, from the specification, design, implementation, and coding. And the process model is basically the representation of that process using, the abstraction. Yeah. So abstraction is, defined through the methodology. The methodology is basically the software development methods, like, the waterfall, V-shape, prototyping model, incremental model, spiral, and the agile. Yeah.
Yep, I
So
remember all that. We went through that, didn't we, on
yeah,
the other unit?
yeah, yeah. So waterfall, it will have again, the same activities: analysis, design, implementation, and testing. But
Yeah.
in which sequence they are being followed, these models, define their own sequence.
Okay. Yeah.
Yeah. So that's about the software engineering at all.
Okay.
Yeah. The rest of the chapters, rest of the books, lots of books, lots of libraries, some of them, they do research on the specification. Some of they write hundreds of books on the design. Some of, writers write books on, the implementation. Some of them write, hundreds of books on the testing.
Yeah.
Yeah. So that's it. And the time is over. And, in the next class, we will, give a little overview of these models, and we will cover the learning outcome too. And you can go through the rest of these slides. I think you have already done. Yeah. And some more topics, from this software engineering unit point of view are there, and you can go through, and I would, cover, as well in the next class.
Okay, thanks for your time.
Okay, welcome, and I see you in the next class. Yeah?
Yeah, thanks. Bye.
Okay, thank you. Bye. Bye.